Hello everyone, this is the second foundation topic in the series of OSPF that we're going to look into it. And in this video, we'll be focusing on OSPF neighbors, so how these neighborship things work. So let's take a look. There are three main phases that OSPF goes through. So first, it becoming neighbor. So this is a relationship between two different routers. Those are connected on the same link. So that is the first step. Once the neighborship is complete, or it moves into a link state information exchange phase. So in this phase, the two routers that has become neighbors start exchanging databases information. So all routers will have a complete picture and a same picture of the topology. So once this process is complete, the third final process, the phase that OSPF moves, is adding the best route in its routing table. So this is the process of each router independently, running the algorithm that we'll look into it, called SPF, and then they add the best route to its routing table. So these concept we'll look into individually. So in this video, let's focus on the first phase, which is becoming neighbors, and on other videos we'll look into different phases of OSPF. So let's take a look how neighborship works. So becoming neighbors. So for two routers to be neighbors, the first thing that needs to happen is a hello packets needs to be exchanged. And these hello packets are sent to a special multicast IP address, which are reserved for OSPF. So the IP address is 224.0.0.5. So that's the number one step. So think this as you move into a new neighborhood or new house, and then you see your neighbors for the first time on a bright sunny day, and then you go, hello, my name is this. So exact same concept. So the routers works the same way. Once the hello packets are sent, there are other parameters this router checks just to make sure we're on the same page. So parameters such as hello timer, date timer, subnet, network type, MTU, etc. So those needs to match. So when you go outside and you tell neighbor hello, and your neighbor looks at you and thinks, I don't think that person is my type, I'm not gonna be their neighbor, right? So something similar concept here. So both router needs to have same information, and they go through this checklist to make sure other information matches as well. And then if everything looks good, they can become neighbors. So to clarify what I'm talking about, let's put this in an example. So we have two routers here, R1 and R2. R1 has a router ID of 1.1.1.1, and R2 has a router ID of 2.2.2.2. So router ID is simply, think that as your name of the router that it uses to represent, just like, we have our name. So that's router ID. So let's take a look how the neighborship actually works. So we have two routers connected using an Ethernet cable, and the link is up. OSPF thing just configure and see how the hello message gets exchanged and they become neighbor. So number one, what happens is R1 sends a hello message to R2 saying, hello, my router ID is 1111 and I don't see anything, right? So think this as a, like in an analogy, think this as you moved into a new neighborhood or a new house, and on a bright sunny day you go outside and you see your neighbor, and then you say, hello, hi, my name is Bob, right? So same thing, the router basically, says hello and then sends his hello message, right? R2 receives this message and takes a look saying, okay, I see somebody wants to be a neighbor because I received a hello message and I can see who is sending it, right? And at that time, what router 2 does, it marks router 1 as its neighbor, but puts them on interim state, also known as init state, and sends a hello message back. So it says, hello, I have seen your router ID, which is 1111, and my router ID is 2222. So let's become neighbors. So it sends that message to R1. So, on our example analogy we're giving, so, you go outside and you say, hello, my name is Bob. And your neighbor listens to that message saying, hello, Bob, my name is Joe. Same concept here. So R1 receives that message and then it checks and says, okay, I receive a new hello message that has my own router ID, which is 1111. And I can also see who sent this hello message, which is 2222. So at this time, I'm going to mark R2 as my neighbor as well, but I'm going to move from init to a two-way state. And last hello message is exchanged. This is going to come from R1. And R1 going to say, hey, hello, I have seen 1111, 2222, and one more time, my router ID is 1111. And R2 receives this hello message back. And then once R2 receives it, it says, okay, I can see my own router ID and plus who is sending it. So I'm going to move into a two-way state as well. Okay. So this is the way neighborship is formed. So at this time, R1 and R2 are neighbor. And if you run show IP OSPF neighbor command, you will see each router placing another router as its neighbor in its neighboring table. So neighborship is formed, two-way neighborship is formed. So let's understand what a init state and a two-way state is. So same router, router 1 and router 2 with same router ID. And let's analyze the first packet that was sent, right? So R1 sends a hello message and just says, okay, hello, my router ID is this, but I see nothing, right? This is when R2 sees the message and puts R1 as its neighbor, but in an init state, okay? So init state in OSPF, it indicates that router has seen hello message from the neighbor, but it does not see its own router ID in hello message, right? Because the scene is null, because this is the first hello message. So the R2, when it receives this hello, it does not see its own router ID in the message. So that is the reason it puts R1 in the init state. And the two-way state, right? So the two-way state, it indicates the router has seen its own router ID in the neighbor field of the hello packet, right? For example, this, when the final hello message gets exchanged and R2 receives the hello message, it sees, okay, I see my own router ID in this hello message, which is 2222, plus the sender, which is 1111, and then it moves to a two-way. So this is how the process works. First, it marked them as an init, and we looked into what that means, and then it moves to a two-way state, and we'll just look into what that means, right? So one more thing, what we need to clarify is, so when the two routers are in a two-way state, what that means is routers has exchanged the hello message. We just looked into it. And router also verified the checklist, such as hello timer, dead timer, MTU, the network type, other parameters are matched. So it goes through a checklist saying, okay, I received hello, things looks good. Let's look into the parameters. Everything matches. Now we can be neighbors. So at two-way state, we can assume all those process has been completed. And now they are ready to exchange the database information, which is the OSPF phase 2, two-way. And that's what we'll look into our next video. So this was a quick summary of how router OSPF neighborship works, how the hello message gets exchanged, and what is the difference between an init state and a two-way state. So we'll look into the phase 2 in our next video, which is the link state information exchange, how database case exchange, what is the meaning of LSAs and LSTP. So all right, I'll see you guys into the next video, and I'd like to thank you for watching.